This is in response to a query about agents and crowds. This query relates specifically to the use of the mirror pose within the rigging system, and specifically this relates to how the rest pose is used within this node within the crowd system. The rest pose is actually very straightforward, however the mirroring is far more complex, and I will provide a brief explanation on how this will be set up. I will not, however, cover any of the simulation of the crowd. The first thing that I'll discuss is the setup for the rest pose. This is actually very straightforward, and most of the time you do not need to worry about it, as the process is actually reasonably automatic. For this I'm going to be using a basic KineFX character. This character was exported as an FBX, but the geometry here is essentially untouched. The mesh is Tommy's geometry, and we'll get this from the first output. The second output will reference the skeleton, and this is the skeleton that the weights are attached to. And the third output will represent the animation. This animation is essentially being applied to the same skeleton we'll have from the second output. In this case, the animation is not from the same file as the character, but the animation can be referenced within the character input SOP. I can also import the same animation separately, and I'm importing this in an FBX animation input SOP. I have specifically exported these files without a rest attribute, so in the animation import node I can select rest pose, and this will cause my rig to flatten out, and essentially this will break the skeleton. This means that I do not have a rest pose as part of this geometry, so I will not be using any underlying information when creating the rest pose for the setup. I'm not going to be treating these as FBX files. I will be using them as geometry, so they will function in the same manner as a standard KineFX rig. We can export FBX files with rest geometry. So for example, we can look at the character output ROP, and here we can store the rest attribute in the geometry by activating rest pose attribute. The default name for this attribute will be rest transform. I would generally recommend using this attribute when exporting the geometry. So I can now begin creating the setup, and the setup will be created without having an existing rest transform. For the setup, I will need to create an agent, and there are two main ways to set up an agent. The first option is to use an agent node. I would not recommend using this node. This is an older node, and it allows for backwards compatibility with the older object-based rigging system, and that's the kind of rig which will be specified if we choose character rig in this node. It can also be used to bring in rigs which are FBX files. I would not generally recommend this option either, as the second option for creating an agent is far more flexible, and that option is the option which I'm going to use, and this is performed with the agent from rig node. This node takes a skeleton, and you will often see this node being set directly from an animated skeleton, so I'll set this with the FBX for the animation. This will create an agent based off this animation, and we will want to make sure that the mesh is attached to this agent as well. To do this, I'm going to use an agent layer node. The agent will be connected to the first input of this node. The second input will be set by the character's mesh, and the third input will take the default skeleton. This skeleton is being used to calculate the deformation of the weights, as the position of the weights is calculated relative to the skeleton. This will give us the agent, and this is the basis of our crowd system. If we want to modify this agent now, we will need to unpack it, and this will be done with an agent animation unpack node. The unpacked animation can then be modified, and in this case I'll be modifying it with the skeleton mirror node. This will mirror the pose, and the pose will work, and it will be correct in terms of positional mirroring, but the actual transforms will not necessarily be mirrored correctly, and we may have issues with deformation. So we do want to have a proper rest pose, as that will make it easier to perform operations as part of a simulation. We have not currently added a rest pose as part of the setup. That, however, does not mean that we have not generated a rest pose. In fact, we have actually generated a rest pose, although the pose which we have generated is fundamentally incorrect. I can access the rest pose using the agent unpack animation node. Here I'll modify the output parameter, and I'll change this from current pose to rest pose. The rest pose gives us a pose which is identical to the current pose, and that's because in this case the rest pose and the current pose are identical. By default, the agent from rig pose will actually generate a rest pose. This is defined in the rest pose from attribute field, and the attribute for the rest pose will be called rest transform. So if we have a rest transform with the matching attribute, that rest transform will be used as the rest pose. Otherwise, this node will generate a rest transform, which will be stored on the character. We also have the option to specify our rest transform off a specific frame. By default, this uses frame 1, but we can specify any of our frames. As stated earlier, we can specify the rest pose using an existing pose, and to add a rest pose to geometry, I'll use the rig stash pose node. The default for this node is to create a pose with the name rest transform, so we do not need to make any updates to this node when we're creating a rest transform. This will be connected before we create our agent, and the first input of the rig stash pose node will be the geometry which you're going to use for the agent, and the second input should be the skeleton of the rig. This skeleton should match the skeleton which is used to deform the character, and we want to apply a skeleton which has no animation on it. This will update the results which we get from the agent node, and when we look at the displayed output of the agent node, we'll see that the skeleton no longer has any deformation, and we can no longer see the animation of the character. What the agent node is now currently displaying is the default transform for the skeleton, and this is the correct rest pose for this character. If we look at the unpacked animation, we are now only able to access the rest pose. The current pose and the rest pose are exactly the same. We can try to specify an agent clip pose, but there are currently no poses registered here either. This is something which we will fix, but before that I want to look at the rest pose again, as what we're doing here is actually redundant, as we do not actually need to stash the rest pose here. If we had the rest pose on the skeleton already, it would be stashed automatically, but if we do not currently have a rest pose attribute, we do not actually need to add it to the rig. Instead of trying to create the agent using a clip, we should actually just create the agent with the default skeleton. Since the agent node will create the rest pose, and the default skeleton is what we need for the rest pose, connecting the default skeleton correctly will give us both an agent and a rest pose for that agent. These changes will give me a warning on the unpack node. This warning is not relevant, but it will not disappear unless I either restart Houdini or create a new node. I now have my agent, and the agent is being created with the default pose, which means that it should use this default pose as the rest pose. This, however, means that I currently have no animation on this character, and I want to add animation poses to the character. To add the animation to the character, I'll need two nodes. The first will be a motion clip node, and I'll connect the animation to this node. And to add this to the agent, I'll use an agent clip node. The first input of the agent clip node will be set by the agent, and the second input will be set by the motion clip. The clip can now be updated, and I'm going to specify that this is coming from a motion clip, and I'll give this clip the name test. I'll activate set current clip, and the test clip can be set to the current motion clip. I will also activate clip time, as this will allow us to preview the animation by scrubbing the timeline. This can now be connected to the animation unpack node. This node is still retaining the warning, so I'm going to get a new animation unpack node, and I should now be able to specify the rest pose. We should now be able to see the rest pose using the unpacked animation. So we can create this rest pose in a number of ways. If we already have the rest pose on the rig, it will automatically be used to create the rest pose for the agent. We could also create this rest pose specifically. However, since the rest pose will be created automatically, creating the agent with the default pose for the skeleton is also a viable option. So now I should be able to unpack the rig using the current pose, and the mirror node will allow us to use this current pose to drive the mirroring operation. So that's how we would set up the rest pose for the mirroring. This, however, will not automatically make the mirroring work, as mirroring is a reasonably tricky operation, and it will almost always give you some form of error. So I have created the rest pose, and we can extract the rest pose directly. The next thing that I want to do is actually mirror this pose, and this is going to highlight a couple of issues that we may run across. In order to use this, I am going to extend the network a little bit. I'm going to get an agent definition cache node, as we will need to cache the information for the characters. I'll then get a crowd source node. This will allow us to create the crowd by using scattered points to generate the agents. So this will give me the main setup, and next I want to add the mirrored animation to the agent. For this, I'll need to convert this into a motion clip. I'll add this clip to the agent using another agent clip node. The first port of this node will be set by the agent, and the second port will be set by the motion clip. This adds the clip to the agent, but the results are not particularly good. The agent's mesh is being broken. The first thing that I will need to do within this node is update the name of the clip. I'll update the current clip, and this will now be test2, and the name of this clip will now be test2. This will update the clips, and we can now take a closer look at the mirroring. Mirroring is always reasonably tricky, as the updates need to be applied correctly for both the names and the points. Getting both the naming and the transforms to work on a generic system is actually reasonably difficult. So we will give the system some more specific information to work with, and this will be done within the rig mirror pose node. Here we're going to update the values used within the mirror operation in the compute mapping options section. The first thing that we can update here is the method. By default, this is set with position and name similarity. Instead, I'm going to work with names. This rig setup does not have the best naming, as it is currently set with a single letter. This should still work, however. Here I'll match my left side with the right side, with the left side being prefixed with L and the right side being prefixed with R. This should give me a much better result straight away. However, I do still have a couple of issues. And here specifically, I have issues with the arms. This is something which can occur with transforms. Transforms are often mirrored using scaling, and in certain cases the transforms may not mirror correctly. These transforms are almost correct. They are actually rotated correctly and positioned correctly. They do, however, have a problem in terms of the handedness being incorrect. To look at the problems, I'll want to visualize the transforms as well as the naming. The visualizations for my transforms have been scaled down. I've given them a length scale of 0.1, and this will make them easier to visualize. I can now look at the transforms, and I will start by looking at the transforms in the mirror pose. And the initial joint that I have an issue with is the elbow. The thing that I want to make sure of with the transform for the elbow is that this transform is consistent with the original transform for the arm. So we can take a look at the unmirrored pose for the rig. The space of the transform for the mirrored pose needs to match the space of the transform for this pose. For my rigs, I'm setting all of these transforms to be right-handed transforms, and they should all have the same axis pointing down the length of the bone. For this rig, I have the Z-axis pointing down the length of the bone, so the majority of the transforms are correct. However, for the elbow, I have a reverse transform, and here the Y-axis is facing the opposite direction from what I need it to be. So this is a left-handed transform, and I need it to be a right-handed transform. There are a number of ways in which I could deal with this. In this case, I'm going to use a rig attribute VOP. I can enter this, and I'm going to begin by getting the getPointTransforms node. I will also need to update the transforms, and for this I'll use a setPointTransform node. I'm going to be updating multiple points, so I will need a for loop. I'll fix the joints where the symmetry is being broken, and currently this is being broken at the elbow joints. So I'll specify the geometry by group, and the group will be specified with @name is equal to *elbow. There will be an issue that we'll encounter doing this, but we'll look at that later. I should now be able to loop over these points. I have got an incorrect for loop here. I should be using a for each loop instead. This will loop over an array, and here I want to loop over the points. The items that I want to update will be the transforms. These are also currently in an array, and to extract these I'm going to use a getArrayElement node. This will be set with the transforms array. I'll get the index of the array using the index from the for loop. The transform from the getArrayElement node will be used to update the transforms in the setPointTransform node, and this will give us exactly the same transforms that we currently have, so we will want to modify these transforms. For this I want to modify the rows of the matrix, so I'll convert this into vectors with the matrix4 to vector4 node. I'll then need to convert these vectors back to a transform, and this will be done with the vector4 to matrix4 node. Essentially we're going to take the matrix, we're going to break it apart, and then we're going to put it back together. The first three rows of the matrix will represent the transform, with the first being the X, followed by the Y, and then the Z. And in this case, the vector which is causing an issue is the Y-axis. I want this to be facing in the opposite direction, and to do this I'll get a negate node, and I'll negate the Y-axis. This will not work properly, but it will fix the issue with the elbows. The arms are being fixed, but the hands are children of the arms, which means that fixing the arms is breaking the hands. So we'll need to perform the same operation for both the hands and the elbows. So we'll re-enter the point VOP, and here I'll update the hands. I'll add them to the getPointTransforms node with @name is equal to *hand. This, however, is not working. To fix this, I'm going to duplicate the rig attribute VOP. I'll connect this after I update the elbows, and here I'll perform the update on the hands exclusively. This is working, so I'll return to the first rig attribute VOP, and I'll remove the hands from this group. I should now be mirroring the pose correctly, and this mirrored pose can now be used within the crowd simulation.